VLSos here. This is a video lesson on common angles. Angles that are common are angles that are commonly used. Also, angles that are easier to use than others. Our common angles are multiples of 90 degrees or pi over 2 radians, 45 degrees, pi over 4 radians, and multiples of 30 degrees or pi over 6 radians. I'm going to sketch a diagram and label all of those common angles. The first ones that we're going to put in our diagram are the most common and useful, those that are multiples of 90 degrees. And first we're going to think of them as radian measures. We're going to think of these angles as angles of rotation that have one side as the positive x-axis. So the first angle is 0 radians or 0 degrees. And the first radian measure as a multiple of pi over 2 is pi over 2. The next multiple of pi over 2 is a half circle or pi. And then if we go another pi over 2, we get to 3 pi over 2 and complete the circle at 0 again, which is equivalent to 2 pi radians. The next angles that we're going to include are multiples of 45, which include the multiples of 90. We're going to do it in radians first. Pi over 4 is equivalent to 45 degrees, and we find the first angle as a multiple of pi over 4 here, approximately. The next is pi over 2, and then in the second quadrant, 3 pi over 4 radians. Pi is a multiple of pi over 4. We get into the third quadrant at 5 pi over 4. And then 3 pi over 2 is a multiple of pi over 4. And the last one before completing a circle is 7 pi over 4. And then 8 pi over 4, which is the same thing as 2 pi. The last common angles that we'll consider in this diagram are multiples of 30 degrees, or in radians, pi over 6. The first is approximately here, pi over 6 radians. The next is 2 pi over 6 radians, and 2/6 reduces to pi over 3. Pi over 2 is a multiple of pi over 6 radians. The next one is 4/6 pi over 3, or 2 pi over 3. And then 5/6 radians, 5 pi over 6. Pi is a multiple of pi over 6. In the third quadrant, we have 7 pi over 12, and then 8 pi over 12, which can reduce to 4 pi over 6. 3 pi over 2 is a multiple of pi over 6. Ten pi over 6, which can reduce to 10 pi over 12, or reduce to 5 pi over 6. And then lastly, 11 pi over 6 over 12, before it completes with one more 6 of a pi at 2 pi radians. These are the standard angles, the most common ones used. And it's worth making a nice large complete diagram for reference. We've begun our diagram. We're going to add now the degree measures of each of these. Pi over 6 is the same thing as 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. Pi over 2 is 90. 2 pi over 3 is 120 degrees. 3 pi over 4, 135 degrees. Pi over 6, 150 degrees. Pi is 180 degrees. 7 pi over 12, 210. 5 pi over 4, 225. 4 pi over 6, 240. 3 pi over 2, 270. 5 pi over 6, 300 degrees. 7 pi over 4, 315. 11 pi over 12, 330 degrees. And then 30 degrees more makes 360. Each of these common angles intersects the unit circle at particular points whose coordinates can be determined. To find the coordinates of these points, I've created two triangles to help us. These triangles are right triangles. One is a 45, 45, 90 right triangle, and if we set its hypotenuse to be a measure of 1, we can calculate the legs to be radical 2 over 2. I have another triangle, it's special, 30, 60, 90. If its hypotenuse is 1, then the legs are 1/2 and radical 3 over 2. If this is a unit circle, it has a radius of 1. And I've made these triangles so that they fit in our unit circle. So if I set the triangle here so that the leg is along the x-axis, the hypotenuse then of a radius of a measure of 1 is also the same as a radius that makes this tip of the triangle the same location as this point on the circle. I can find the coordinates of this point from the legs of the triangle. The coordinates of this point is the leg, or x value of the point, radical 2 over 2. And the y value of the point is the measure of this leg to get up to the point of radical 2 over 2. The angle associated with this point is also the angle found in this triangle of 45 degrees, or pi over 4. So the coordinates of the point associated with the angle of rotation of 45 degrees, or pi over 4 radians, is radical 2 over 2x and radical 2 over 2y. I could take my 30, 60, 90 triangle and fit it into the circle, such that the hypotenuse measure of 1 is also a radius of the circle. The angle created by that radius is 30 degrees, or pi over 6. So this angle intersects the circle at this point. We can find the coordinates of this point as the legs of this triangle. Radical 3 over 2x, 1/2 y. I can make a note of that. The coordinates of the point are radical 3 over 2, 1/2. I'm going to do this a couple more times. I can use this triangle to show the angle in it of 60 degrees that corresponds to this point as a rotation of 60 degrees, or pi over 3 radians, and find its coordinates from the legs of the triangle. In this case, 1/2 x and then radical 3 over 2y. This point here, I don't need a triangle for. the measure is 1, and the coordinates of this point is 0x, 1y. The remaining coordinates of the other points in the other quadrants can be found by reflections of these points in the first quadrant. This point here at 135-degree rotation is symmetrical to this point here at 45. So the coordinates of this point are going to have the same magnitude, radical 2 over 2, radical 2 over 2, except that the x value of this point will be negative because we have to go backwards by radical 2 over 2 to get to that location. This diagram can be completed by filling in the coordinates of all of these points. Doing so will provide a very nice and helpful diagram to do trigonometry and find the measures of angles and associated angles in future work.